Hello ladies, gents, and everyones. It is Thursday, March 10th, and we're here to talk about this week's space and astronomy news. NASA is in the middle of opening up an Apollo lunar sample for analysis. Wait, Apollo? Wasn't that like 50 years ago? Yep. This sample was taken during Apollo 17 in 1972. Some of the Apollo samples were sealed at the time so they could be studied in the future with better technology and newer techniques. And this sample is one of only two that was actually vacuum sealed when it was taken on the moon, and the first one of those two to be opened. The opening process started back in February, and it will take months to ensure that scientists are holding on to every bit of those possible trace gases. So far, they've opened up the outer chamber and found that the inner chamber's seal still seems to be intact. And now they're in the middle of piercing that inner seal and extracting the gases. These gases will be studied with modern instruments that can detect and precisely identify even very tiny amounts of gas. Very cool that this sample has survived to be analyzed by us now, and just can't wait to see what they find inside. The very first exoplanets ever discovered were actually not orbiting a star, they were orbiting a pulsar. So pulsars are highly magnetized and rapidly rotating neutron stars. So these planetary systems are really different than our own, but the precise timing of the pulses from a pulsar make it a lot easier to detect planets. So the fact that pulsar planets were the first ever detected is more about the sensitivity of the detection technique than it is about how common these kinds of planets are. So a new study just published has looked at a catalog of existing data for 800 pulsars to see if any of them have signals of planets. And they found only one plausible candidate for pulsar hosting planets in this sample. These results implied that fewer than 0.5% of pulsars likely host planets similar to those very first ever found exoplanets. So that pulsar does indeed seem to be a very rare case. In chemistry, organic doesn't mean that you bought it at Whole Foods, it means that it's a molecule containing carbon-hydrogen bonds. And these type of molecules are really intriguing because all of life that we know of is based on organic compounds. And now ALMA has detected the largest ever organic molecule in a protoplanetary disk. The molecule is called dimethyl ether, and it has 9 atoms. While scientists knew that dimethyl ether existed in the cold gas and dust clouds that stars form out of, they had never been able to detect if that organic compound was still present in the protoplanetary disks, which are the disks of gas and dust around a newborn star out of which planets form. This detection means that the organic compounds that are the building blocks of life that make up amino acids and sugars are present in the formation of planetary systems. Good news for the possibility of life in other systems and for understanding how life formed here. The Earth is under attack, constantly, by rocks. Now we're protected by our atmosphere from the most frequent type of rocks that hit us because they just burn up. But the larger ones can reach all the way to the surface and they can have really big consequences. Sorry, dinosaurs. Now, back in 2018, researchers found a large impact crater underneath a glacier in Greenland. The crater is 31 kilometers wide, which is really quite significant, although for comparison, the likely dinosaur killer impact crater is like 180 kilometers wide. So while an impact like this wouldn't have killed off the dinosaurs, it can alter the climate of Earth for a significant amount of time. And when this crater was first discovered, they saw hints that it might be relatively recent, that is, just in the past few tens of thousands of years. So some considered it a possible source for a millennium-long cooling period that occurred about 13,000 years ago. Now, this crater is buried beneath a kilometer of ice, so precisely dating it is really difficult. But scientists found some rocks in the deposits from the glacier that actually showed signs of being present at the time of impact. And they were able to use radioactive isotopes in those rocks to precisely date the time of impact. And it turns out that the whole 13,000 years ago thing was a little bit off, because now they think it's actually 58 million years old. Fascinating example of how much the Earth is affected by the rest of the solar system and how much we can learn about the past just by looking at things that we have now. Lastly, we talked last week about how Russia's invasion of Ukraine has consequences in many areas, but specifically in the space arena. Unfortunately, the invasion is still ongoing and these consequences are continuing to evolve. The European Commission has suspended all cooperation with Russian entities in research, science, and innovation. The ExoMars rover is an ESA-Russia joint mission which was supposed to launch to Mars this year but is now going to be delayed. Germany has suspended all research cooperation with Russia, including shutting down the eRosita X-ray instrument that is currently on board the Spectre RG Space Observatory. CERN has suspended Russia's status as an observer, and Scott Kelly, a former NASA astronaut, has been having it out with the head of Roscosmos on Twitter, at least until he got blocked. Which, side note, how weird is it that this sort of thing happens on Twitter? I've been on Twitter since like 2008, and it's wild to me. So Kelly has now stated he's going to be returning his Russian medal for merit in space exploration, saying, "Please give it to a Russian mother whose son has died in this unjust war." So in summary, really, everybody loses. I gotta stop ending on such depressing news. But that is all I have for you this week. Thank you so much for watching. I really appreciate all of you. Again, I really hope that you are all doing as just well as you can out there right now, and I will see you again next week. Have a good one. Bye.